Okay, so this is the recording for our group 6 static from BMMV section 1. So our group members are Muhammad Izzuddin, Anas, and me myself, Yahov Sun. So the question 1, a design model for transmission line tower is shown in the figure. Member GH, FG, OP, and NO are insulated cables, so we know here all these are the insulated cables, and all other members are steel bar. So all this member is the steel bar. For the loading show, compute the force in the member KL, PQ, FH, EJ, and DS. Okay, so we see here KL, PQ, FH, EJ, and DS. DS is down here below. And use a combination of method if desired. Okay, so we seen here. Since this is a structure is symmetrical, so both downward force acting on this structure is 25 kilonewton with the same equal dimension on both sides. So we can conclude that KL is equal to JK, PQ equal to FE, FH is equal to the opposite side, PN, and the SDS is another part. So first, for the calculation, I will only use one side of this part, either this part or this part. So for my calculation, I will use this part, the left side of this structure. So first step is to find all the length and the angles. So as we can see here, this is not the free body diagram, just a simple diagram for the structure to find all the angle and the dimensions, all the lengths. So first, I will start with finding the angle for alpha. Both sides of this is the alpha. So alpha equal to 12/6. So alpha will get 26.57 degree. So alpha is 26.57, where 6/12. 12 means that from 4 plus 4 plus 4. HI equal to IJ. So by using cos, HI equal to IJ. By using cos, we know that to find this length, we can use cos, since the hypotenuse is 4 meter is given here. So HI and IJ equal to 4.46. HK, we'll get HK from square root of 12 squared plus 6 squared. 12 squared, where this is the length and this is 6 squared. So we can see here this is a right angle triangle. So HK equal to 13.42 meter. So JK, we will find JK. Since HI equal to IJ, then all this HI equal to IJ and equal to JK. So this is equal length. So we will just need HK minus 2HI, or HK minus HI minus IJ. So we will get here 4.47 also. So we can conclude that HI equal to IJ equal to JK. At point F, we can find the degree angle beta, where this is angle of 90 minus alpha, and this is also 90 minus alpha. So this is a straight line. 180 minus 90 minus alpha minus 90 minus alpha, we'll get beta. So we can get beta 53.13. So another step, we proceed. Tangent 26.57 equal to J E prime, where E prime actually not exist here. I just assume this point is the E prime. So E prime, so we will find J E prime equal to 4 meter, where J E prime is equal to 4 meter as it's written here. So by using this right angled triangle, and we proceed, cos 26.57 equal to 4.47 over HF. So we'll get HF equal to 5. HF equal to 5. Sin 30 equal to GH over 5. Sin 30 equal to GH over 5. So GH equal to 2.5 meter. GH equal to 2.5 meter. So we proceed, this is step number 8, and we proceed to step number 9. Cos 60 to H prime over 2.5 H prime. So H prime, I assume this is the H prime, where actually H prime is not really exist here. I just make an assumption where H prime is here. So we'll get H to H prime is 1.25. H to H prime is equal to 1.25. Then H prime to F prime equal to 4 minus 1.25. So we'll get H prime F prime equal to 2.75. So 2.75 is actually here. This is the F prime. This is the H prime. So length distance from H prime to F prime is 2.75. Okay, so tangent Y, to find the degree Y equal to 2.7 over 30. So actually this is a shortened diagram for KA. So this is the Y. 30 is mean that all the length from here to here is 30. Well, this is 5.4 divided by 2 equal to 2.7. So we'll get the angle of Y. Tangent 5.14 equal to EQ over 2 over 6. So 1 over 2 EQ equal to 0.54. 0.54 is here. So this is 1 over 2 EQ. 1 over 2 EQ, this is the midpoint of EQ. This is the midpoint. So HJ equal to 2HI. So we can see here HJ equal to 2HI. So 2HI will equal to the length of HJ. So we'll get that HJ equal to 8.94. H equal to 12 minus 0.54. So H equal to 11.46. He equal to 1.46, where all the length from H to the midpoint of EQ equal to 12, as we can see here. This is the dimension. So minus 0.54 equal to HE. JE. JE, I will use the formula of Trigo, where we already have the length for HJ, HE, and the angle between HJ and HE. So we'll get the length for JE, 5.29. So JE, we'll get, this is the length of 5.29. And we proceed. I proceed with step number 16, where I still use the formula of Trigo to find the theta. Theta is here. So we already have the angle here and the length, and the angle here and the length. So we can find the theta. So theta we get 49.11. Z, for the degree of Z, X, and W. So this is just mathematically 90 minus 53.13 equal to 36.87. So Z is here. Because we already have beta, so 93 minus beta equal to Z. Okay, X, 90 minus 49.11, so equal to 40.88. And W equal 180 minus 90 minus 36.87 minus 26.57. W equal to 26.56. So as we can see here, x, we already have theta. 90 degree minus theta equal to x. So we'll get the x here. So this is w. This is 90 degree. 180, a straight line here, minus 90 degree, minus z, minus alpha equal to w. So we'll get w, the degree angle of w. So all this angle and the length is needed in order to solve this question. So we continue with the free body diagram. So I'll make a cut section from here to here. So I will cut it from here because I wanted to find JK, JE, FE, and HF. So I will cut from here to here. So as we can see in the free body diagram. So first step, by taking moment at J. Here is the J equal to negative FE, where this make a clockwise direction, so it is negative, plus its perpendicular distance 4 plus 25k will make anti-clockwise, so it's positive, and the distance, perpendicular distance of 25 kilonewton is 4 plus 2.75. So we'll get FE. FE is this 42,187.5 Newton. So we can see here from this direction, this is a compression. And so since HF and FE is a single, can be said a single member, since they are in a straight line, so they both will have equal amount of force of compression. So the value is 42,187.5 Newton. Another step, second step, by taking moment at point H. Then by solving this 25 kilonewton multiplied by its perpendicular distance 1.25, you make a clockwise direction. So this is negative, plus JE for cos. This JE will make anti-clockwise, so it's positive, and the perpendicular distance is 8. 4 plus 4 will make the vertical force for JE. And for the sine, where the horizontal force for JE, equal to sine 40.88, where is from here x equal to 4. Sorry, not equal to 4, by multiple by 4, where 4 is the perpendicular distance. And so we can get that FJE equal to 3,605.81 Newton. From the direction, we can see that the force actually is a compression force. And in order to find the force JK, by using sum of force for the y component equal to 0. So by solving this angle, we'll get FJK sine 26.56 minus 25 kilonewton plus F force JE outwards position. So we'll get FJK to 49,814.31 Newton. From direction, we can see that FJK is actually a tension force, where this is the second part of the method of section. And by using application of equation of equilibrium, so this section is actually from, I cut it from here, this upper part. Since we already have JK, JK will be equal to KL since this both side is actually symmetrical. So with these two force, we can actually find for the force K to A and K to U. Since this is a single straight line, so all these members in a straight line will have equal force, equal magnitude of force. So by solving it, by using the sum of force of vertical direction equal to 0, so we can see that FKA equal to FKU. FKA will be equal to FKU since this is actually the same because it is symmetrical. So by solving all this, downward force will equal to upward force. So we can find by assuming that FKA equal to FKU equal to 2 FKA multiplied by cos 5.15 equal to 44,562.97. So I will get that FKA is actually 22,371.45. So I can see that FKA and FKU actually will have the same magnitude and the force is actually compression force. Then this is the line for F from K to A. So this is only one section. This section is from here. So we will find ds with the force from here. We can use the force to find ds. Okay, so first I will start finding all the angles and the length. Oh, sorry, not the length, just the angles. So this is the angle 5.14. So I'll get CS, where the C to S is 3.24 meter, and tangent 5.14 equal to CS prime, where S prime is actually here. I assume that S prime is here. The vertical from vertical D. So C to S prime. So the length is as shown below. So C S prime equal to 0.54 meter. So S prime to S equal to 2.7 meter. Tangent X, so tangent X equal to 2.7 over 6, X equal to 24.23. So we'll find the theta, where 180 minus 90 degree minus 5.14. So theta, this is the theta for here. Actually it will equal to 84.86. So then we apply equation of equilibrium where Fy equal to 0. Sum of Fy equal to 0. So we will get FDS equal to 0. Since FDS equal to 0, therefore FDS is a force member. Downward force will be equal to the upward force. Downward force will be equal to upward force. So that's all from me. So this is all the force for the member. So we will proceed with the question number 2, where Muhammad Izzuddin will present for the explanation of step number 2 and 3. Okay, thank you.
Hi, Assalamualaikum. So I proceed to go to the next question. My name is Muhammad Izzuddin BMD Rajimin. So I will explain to you how we solve question number 2. So as you can see, the question said determine the magnitude of the gripping force produced when two 300 Newton force are applied as shown, like this one and this one. So it the same force up and down. Okay, the first one we gonna make a FBD at the point C and B. So this member we're gonna take it. So the FBD will be like this one. F point B and C. After that, we make a equation of equilibrium and we taking the moment at the point C. Okay, the first one we determine moment at the point C. Total moment C equal to 0. So we get the first one negative by. So by this. So point C here. So when the force is going down, so it will be clockwise. So that's why it's become negative by. So by divide tak lepas ke? Okay, so like we continue like negative by at the point moment C. So we got the negative by time to 12 is displacement this one. So time to power negative 3 because I want to change to meter. So and then minus 300 this one force minus 300 and the displacement we got the here 490 time to 10 power negative 3 and then we gonna plus bx here time to displacement 24 this one time to power 10 negative 3 equal to 0. So we got the by equal to 300 times 48 times 10 power negative 3. So we got the by here equal to 11,200 Newton. So the second step is we gonna make a FBD at the point A and B. So the FBD looks like this at this point A and B. And at the point A and B, we're gonna make we're gonna taking a moment at the point A. So the question is total moment A equal to 0. So the force time to displacement 24 here equal to time to 10 power negative 3 minus by here by times to 99 times 10 power negative 3 equal to 0. So we got this one. So the force is 4 by for the FBD at point A and B. Okay, after that we're gonna make a FBD at point A and D. So the FBD will looks like this. So we got we take a moment at the point A. So the question is total moment A equal to 0. So dx equals 0, ax equals 0, and bx equals 0. After that, we're gonna make we're gonna put a sub 1 into the sub 2. So we get the F force equal to 4 By, and By we get already this one. So 4 times to 11,200 Newton. So we got the force 44,800 Newton. Okay, that's for the question number 2. So we proceed to question number 3. The bucket of the front end loader shown carries a 3,000 Newton load. The motion of the bucket is controlled by 2 identical mechanisms, only one of which is shown. Knowing that the mechanism shown support 1/2 of the 3,000 Newton load. So determine the force by cylinder CD and member AB, by cylinder FH, by pin G. So we're gonna determine CD, AB, and FH at the pin point G, this one. Okay, the first one, we make a FBD at point A and D member. So since the mechanism shown support 1/2 of 3,000 Newton, so we divide that for 2 for half. So we got the 1,500 Newton here. So we take in moment at the point D. So total moment at point D equal to 0. So we got the negative FAB here, because it's clockwise, so that's why it's negative. So time for displacement 0.4 here, and then plus to 1,500. There's a lot of weight, time to 0.4 here equal to 0. So we got the FAB 1,500 Newton. And then we move to FBD at the point BCDE. So here the FBD, as you can see. And the first one, we got a angle here. So we use the tangent theta equal to 0.2 and 0.1 here. So we got the angle is 63.43 degrees. And then we use the equation of equilibrium. So total Fx is equal to 0 and total Fy equal to 0. So we go to the total Fx first. So we got the negative EX here, because at the negative side. So negative EX plus 158.4 cos this one, cos angle 63.43 and minus 1,500 equal to 0. So we got the EN 2,999, and after we got the ES, we go to the equation for total Fy equal to 0. So we got the 1,058.4 sine, because here sine 93.43 minus EY, because it downward, equals 0. So we got the EY is 96.12 Newton. And then we taking the moment at the point E, this one. So total moment E equal to 0. So 1,500 times to 0.8 here. and then minus FCD, and FCD cos 63.43 times to 0.4 here. And then we plus FCD here, FCD sine 93.43 times to 0.1 equal to 0. So we got this one, 0.089 FCD equal to 1500 times to 0.6. So we got the FCD 158.4 Newton. So it I said it it's a compression force. After that, we go to FBD at point DEFG. The point DEFG. This one, DEFG. Because we want to get the pin at point G, right? So we got the angle, two unknown angle here. So the first one, tangent 1 here, tangent theta 1 equal to 0.2 divide 0.5. We got the theta 1 21.08. So the theta 2 tangent equal to 0.2 divide 0.1. So we got the angle theta 2, 45 degree. So we use equation of equilibrium. So total effect equals to 0. So we got the negative 158.4 cos 21.8 plus 299 here, 2999, and minus 336,809.04 sine 45, this one, times sine 45 plus GA equal to 0. So we got the GA is 32,368 Newton. So after that, we total Fy equal to 0. So we got the negative 158.4 times to sine 21.4 plus 89,996.12 plus 36,809.04 times to cos 45 degree minus GY equal to 0. So we got the GY here, 31288.64 Newton. After we got total Fx and Fy, we take a moment at the point G. So total moment at point G equal to 0. So we got the FFG sine 45 times 0.15 minus FFN cos 45 times 0.6 minus 2999 times to 0.18 plus 0.15 plus 0.3 minus 8996.12 times to 0.5 plus 0.6, and then we plus 158.4 sine 21.80 times to 0.4 plus 0.5 plus 0.6 negative 158.4 cos 21.08 times to 0.2 plus 0.3 and plus 0.15. equal to 0. So we got this one, and we get the FFN is equal to negative 36 809.04 Newton. So it's a compression force. So that's all from me. So we move to equation number 4. So I will invite Anas bin Kusairi to explain the equation. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Anas bin Kusairi. I will explain about the question for number 4 and number 5. So we go for the question number 4. We can arm ABC is connected by pins to a collar at B and to crank at C. Negating the effect of friction, determine A, the couple M, force at pin B, pin C, and pin D. Required to hold the system in equilibrium when theta is 0 degree and 90 degree. So first step I use is when theta is equal to 0 degree lah. And at this FVD we can see 240 Newton, which at moment at C equal to 0. Summary of moment at C equal to 0. So 240 Newton times and its distance is 180 plus 320 millimeter times by minus B, force at B, times its distance perpendicular, so 160 millimeter equal to 0. So we can get from this equation, we can get the force was acting at point B. So the answer for point at B is equal to 750 Newton. And after that, we can find the CY and CS after we have done for this equation. So summary of Fy equal to 0, we can get Cy minus B equal to 0. So Cy equal to 750 Newton because this B, we just put it here. And for the summary of Fx equal to CS equal to 240 Newton. It's same with this force. So for this FBD, we must use Fx, summary of Fx equal to 0, and dx. For this dx and cx, when dx minus cx equal to 0, and we can get dx equal to 240 Newton. For the Fy, summary of F5, dy minus by cy equal to 0 Newton. So dy we get 750 Newton. So this answer we get from this equation. For moment at D equal to 0, so moment D 750 Newton times by 300 millimeter, 300 meter, minus by negative 240 times 125 for the distance. So negative 240 Newton, this was dx because it's negative because of it was clockwise, dx clockwise, so it anti-clockwise, negative. So moment at this is 195 Newton. So we use the same FBD, but different theta is when theta equal to 90 degree. So for moment at C equal to 0, negative 240 Newton times by 160 millimeter and 90 millimeters for this distance, plus this B and times by 160 millimeter. So we can get B is equal to 375 Newton. For the summary of Fx equal to 0, Cx we can assume it as 0, and Fy summary of Fy equal to 0, negative 240 plus 375 for this point, negative 240 for this point, and minus by Cy equal to 0. So we can get Cy equal to 135 Newton. For this FBD, summary of Fx equal to 0. This Cx and dx was same, equal to 0. So for the summary of Fy, dy equal to Cy. So dy equal to 135 Newton because of this lah, Cy equal to was same as dy. And moment at point D, summary of MD equal to 0. So MD equal to 135 times by 300 millimeter. So we get the answer is 40.5 Newton meter, and we can say it was anti-clockwise. Okay, for the question number 5, two hydraulic cylinders control the position of the robotic arm A, B, C. Knowing that in the position shown the cylinders are parallel, determine the force at stand A by each cylinder by pin B at support F when P is 250 Newton and Q is 150 Newton. This P 250 Newton and Q 250 Newton. So for the FBD of AB, we must to find the moment at B first lah, equal to 0. So negative 250 times negative 250 times 600 plus FAE 4/5 times 150. So we can get the FAE answer is equal to 1250 Newton. After that, we still use the same FBD for summary of Fy and Fx equal to 0. So for summary of Fy equal to 0 is negative 250 plus By negative 1250 4 times by 4/5 equal to 0, and we can get By is 1250 Newton. For the Fx equal to 0, negative 150 plus Bx minus negative 1250 times 3/5 equal to 0. So we can get Bx 900 Newton and By 1250 Newton for this Bx and By. For the second FBD, AE, BF, DG is parallel to each other. DG, BF, AE. So we can get the theta is, for this theta we must to find, because this all was 90 degrees, so 90 minus 36.87, so we can get this theta is 53.13. So for after that we must to find this x and this y, so we must use the formula for sin cos tan. So for x we use the tan formula, tan 53.13 equal to 400 times 10 power of negative 3 over x, so we can get is 300. So for this y, cos, we use the cos formula, cos 36.57 equal to y over 200 times 10 power of negative 3. So for y we get 160, and after that we can find the moment at F equal to 0. So summary of moment at F equal to 0 equal to FDG times the distance is 160 minus 1250 times 300 plus 900 times his distance is 400 equal to 0. So we can get the this FDG, and it was 93.75 Newton. For the Fy equal to 0 and Fs equal to 0, we can get this point and this point, its force. So for summary of summation of Fy equal to 0 is Fy plus FDG cos 36.87 minus By. So for FDG we get from here, for By we get from this equation. So we can get the Fy is 1175 Newton. For the Fx, summary of Ff equal to 0, Fx minus Bx plus FDG sin 36.87 equal to 0. So we just put this answer at this equation and this answer for this question. So we can get the Fx, the force at point Fx is equal to 843.75 Newton. So that's all from me, and that's all from our group. Thank you Dr. Hairul.